In the last two lessons, we've been solving inequalities using addition and subtraction, and then multiplication and division. Today we're going to put those together and solve multi-step inequalities. And we follow the same rules we follow when we're solving equations. It's just that we have to add in the rule that we learned with multiplication. We have to change the direction of the sign. So let's start with a pretty basic one. 3x minus 7 is less than 8. We start by adding 7 to both sides. We have 3x is less than 15. Then we divide 3 out of both sides. We get x is less than 5. So we followed the same steps we would have if that had been an equal sign. And then, if it instructs us to, we graph our solution, which would be a number line with an open circle at 5 and an arrow going to the left. Our next example is negative 0.6 times x minus 5, which is less than or equal to 15. Now, we have two choices to start with. We can use our distributive property to distribute that negative 0.6 through to the x and the negative 5. Or we can divide both sides by negative 0.6. If we do that, we're left with x minus 5 on the left, and what do we have on the right? Negative 25. Now, since we divided by a negative, we need to switch the direction of our sign. If we'd used the distributive property, eventually we would have still divided by a negative, and we still would have had to switch our sign just at a different step. Our last step in this inequality is to add 5 to both sides, bringing us to x is greater than or equal to negative 20. Again, if they ask us to graph that, take our number line, we'd start at negative 20, and since we have greater than or equal to, we'd put a closed circle there, and all of the numbers that are greater than or equal to are to the right. What if we have variables on both sides? Well, we follow the same rules we're following with equations again. Now, one of the ways we can avoid dividing by a negative number is to always move the variable with the smaller coefficient. So since 2 is smaller than 6, if we move the 2x, then we're going to have 4x minus 7 is greater than 17. Adding 7 brings me to 4x is greater than 24. So I'll be dividing by a positive 4 instead of a negative 4, and I won't need to switch my sign. I get x is greater than 6. Now, some inequalities will have multiple solutions, and some will have no solutions. Let's look at when that would be the case. 14x plus 5 is less than 7 times 2x minus 3. Let's start with the distributive property on the right-hand side. Our left-hand side stays the same, and the right-hand side becomes 14x minus 21. If we subtract 14x from both sides, we are left with 5 is less than negative 21. Is that true? It's not, because all negative numbers are less than all the positive numbers. So this can't be true. This is a contradiction, which means there are no solutions. There's no values that we could plug in for x that would make this inequality work. On the other hand, if we have a problem like this, when we use our distributive property, come to 12x minus 1 is greater than 12x minus 6. Subtracting 12x from both sides gives us negative 1 is greater than negative 6. Is that true? It is. -1 is bigger than -6. It's further to the right on the number line. And so no matter what we plug in for x, we would get the left-hand side always being bigger than the right-hand side. So that means any number that I plug in for x is a solution, so we write all real numbers. That means that all real numbers are solutions or values that we can put in for x to get a true statement. Why don't you try a few of these inequalities on your own. 5x minus 12 is less than or equal to 3x minus 4. 5 times m plus 5 is less than 5m plus 17. And 1 minus 8s is less than or equal to -4 times 2s minus 1. Give those a shot. When you're ready, unpause the video and we'll see how you did. Okay, so with the first one, we start by subtracting 3x from both sides. Leaves us with 2x minus 12 is less than or equal to -4. Adding 12 to both sides brings us to 2x less than or equal to 8. Dividing by 2 gives us x is less than or equal to 4. Now you may have used a different order in your steps. That's okay, as long as you come up with x is less than or equal to 4, or equivalently, you might have come up with 4 is greater than or equal to x. For the second one, we would use the distributive property on the left and subtract 5m from both sides. Gives us 25 is less than 17. Is that possible? No. So there is no solution for this problem. The last one, we'd start with the distributive property. And then we would add 8s to both sides because we have -8s. Which gives us 1 is less than or equal to 4. Is that true? Yes, so our solution is all real numbers because any value that we could put in for x would make our inequality true. Let's try a word problem. Gasoline costs $2.09 per gallon. A car wash is $8. The gas station charges 10 cents less per gallon of gas if a customer also gets a car wash. What are the possible amounts of gasoline that you can buy if you also get a car wash and can spend at most $20? So since we can spend at most $20, that means that our total cost needs to be less than or equal to $20. So let's think about where our total cost is. We have to get a car wash. That's $8. And that's a flat amount. There's no $8 per gallon or anything like that like there is with gas. Now, since we get a car wash, our gasoline is 10 cents less, bringing it to $1.99 per gallon. So the question is, how many gallons can we get on our budget? And so the total amount we're going to spend on gas is $1.99 times the number of gallons we get. So this is the total amount on gas. And this is our car wash. And it has to be less than our budgeted amount. So now we want to solve this inequality to find the possible number of gallons of gas we can get. We subtract 8 from both sides. Gives us $1.99. G is less than or equal to 12. If we divide both sides by 1.99, we find that we can get up to, but no more than, 6.03015 gallons. So we can get just a little bit more than 6 gallons of gas before we run out of money. A lot of these situations, with budgets and things like that can be set up with inequalities. You just got to take your time and know where your terms are going. If you have any questions, feel free to ask. You can go back and watch the video if you need something clarified. Otherwise, you can move on to your homework.